This is example 2 from 9.3 from Math 20-1. Just looking at another quadratic inequality, and they're presenting it in a different form. It might not be a bad idea to practice your chapter 3 technique and complete the square on this, but I'm going to show you another way of doing it as well. The first thing that I would do in this question is I would factor it. So I'm going to say that y is greater than or equal to, this is going to be factored as x minus 5 times x plus 1. Now, the reason that that's an advantage is that if I were to graph y equals x minus 5 times x plus 1, then on that graph, we now know through the factored form that we have an x-intercept at positive 5, so I'll put 5 comma 0 beside that, and we have an x-intercept at negative 1 comma 0. Now, one of the things we talked about in Math 20 was the idea that parabolas are symmetric about their vertex. And it's been a while since you talked about that, I get that, but the symmetry concept is important in math, and human beings have symmetry. If we drew a dotted line through the middle of our forehead and our nose, we would be roughly equal on either sides of that line. Parabolas are like that as well, except they're symmetric about the vertex. I don't know where the vertex is, but if I know two x-intercepts, then the vertex has to be halfway in between those x-intercepts. Halfway in between negative 1 and 5 is positive 2.5. Now, I want to show you how to do that. I'm essentially just finding the average of those numbers. I think it's actually positive 2. I did that wrong. We'll take a look. What I would do to find the average is I would take negative 1 plus 5 and then divide it by 2. That becomes 4 divided by 2. So that is going to be at positive 2. Now, and it should make sense that if I look at positive 2 right here, positive 2 is 3 away on the x-axis from 5 comma 0, and 3 away from negative 1 comma 0 on the x-axis. So it does make sense that positive 2 is in the middle. I'm just going to get rid of that writing. But if I know, and I'm going to put that here, that my vertex is when x is equal to 2, what's my y value? Well, I can use my factored form for that. And if x is equal to 2, then y is equal to 2 minus 5 times 2 plus 1, which is y is equal to negative 3 times 3, so y is equal to negative 9. Now that means that my vertex is at 2 comma negative 9. And we didn't really need that, but I think it is a big advantage to see those 3 points on that parabola, because then I can simply connect them. And I drew the right line this time. Because y is greater than or equal to x minus 5 times x plus 1, I would use a solid line for this graph. All right, the last part then is to determine, do I shade in above it or do I shade below it? Now, some of you may have looked at the original question and you already know that we shade above it, and that's awesome. That is a good place to be. What I am going to use is my favorite test point, which is 0, 0. I know that that is clearly above the function, so I'm going to test 0 comma 0, and when I do, I get that 0 is greater than or equal to, and I'll use the original here, 0 squared minus 4 times 0 minus 5. I get that 0 is greater than or equal to negative 5. Is 0 greater than or equal to negative 5? Absolutely. And so that means that that test point is within the shaded region of this inequality. Now, just as a quick reminder, remember that inequalities have regions or ranges of solutions. Any point in that blue, wonderfully shaded region is a valid solution. And so when we talk about graphing inequalities, we are talking about solution regions, not a single solution. And that's a really, really important distinction between equations and inequalities. Inequalities have lots of answers. Equations have a discrete number. They can technically have infinite answers in Math 30, but for now this year, we typically say they have, 1 or 2 or 3 or some, smaller number of answers. All right, that's the second example, and we'll go on and we'll try some harder ones and some word problems as well.